ready, ladies and gentlemen. Today I'm going to do the soldering, if I can. Oh my god, please, here we are. So I have this transformer. This is a neon transformer. I have 10 to 30 watt 5 kilovolt and output at 30 milliamps. So basically it takes the 240 VAC, which is alternating current from the outlet at 50 hertz, if I'm correct, and then basically it creates, or it is going to create a zap between these two lines. So one is going to be put onto the top of the what do you call it, the wanna show, wanna take it here. So I do have the wood ignition guy here, or the basically the chamber itself. So the cap, or this washer, goes onto here, and it basically is just locking itself there, and the other goes onto this thing, and basically I can like close it, and that's it. And basically that is it for now. Later it will be probably changed up. So yeah, I have these things. Can't even get this out. Great. So what I wanted to do is, yes, solder. No, these are not going to be soldered. This, and on the other side the 30 volt is going to be soldered. I'm going to break this up. I'm going to take it will be, I mean, whatever. I will take the, let's say the green, brown one. I never know. I think the brown wire is the plus, and this is the blue wire is the 0. So this is not the plus, the phase, and this is the 0. So basically this is that what we need to switch, and this is what we don't need to switch, and this can be walled up. The main thing is that it doesn't matter which one is which, because if you plug it into the outlet the wrong way, then it's still not going to be working as intended. So yeah, I'm going to take this off, and then I am going to put this back, then I'm going to take this apart, and then I'm going to solder it up. So what we will need is that I need to take this end off. I think this is, oh, pretty good. It's in the middle. So great. I need to take the I'm going to put this here. Cut away from myself. Today I have already injured my finger, so probably not the best soldering work here. What I would say is that it doesn't really matter, because now I will fucking heat shrink. This looks like shit, honestly. It was not my best job, I would say. Yeah, I basically heated the thing and then I think this didn't fit, so that's why I use this green as well. I'm just going to use this cutting technique here, slide the whole thing up in the middle, then peeling off. I think I already plugged in the Millennium Falcon. I'm going to desolder. By the way, I have just ordered the PCB out. It's like a terminal block, or like a I wouldn't say terminal block. It's, what do you call this? A socket adapter. I need to. Alright, so I will be able to see everybody's writing here. So I have just ordered the socket adapter, which is basically for the level sensor that I'm going to build, and also I will need to buy additional stuff like the air I don't know what to call this, air assisted work, whatever. It's basically a soldering iron which is just uses hot air workstation. I think that's the name. This looks terrible. Who is who? Doesn't say, does it? No, it just says the input output. Well, thank you very much. I mean, doesn't really matter, does it? Okay, so what I will do is I will be able to put yeah, I need to crimp these, so I need to use these terminal ones. So yeah, who could this be? Red 40. Honestly, this is a joke. Okay, half of the shrapnel that I have cleaned off from the parts ended up probably into my computer, which is not the best thing. I don't think this is going to fit. Yeah, let's see. No, this is not going to fit. So red is out. Let's go with black. Once you go black, you never go back. Blue, not good either. Blue. Yeah, blue. Okay. Did the other one fit? No, it does not fit. Oh yeah. I mean, I can cut. I mean, yeah, it's pretty long. It's unnecessarily long, so I will cut away a bit. I mean, a bit, half of it. Yes. And then we'll see again if we can pull the blue on this one, but I think we can do. I think it's fine. And I cut a bit too much. Oops, doopsie. Okay, I think this is sort of okay. And what I did not check is that will this fucker fit into the terminal block? Because it is nice that I creamed this onto here, but will it fit? Will it fit into this little fucker? Because that's the point that I want to solder the, or not solder, but like, you know, comb, which is this. Where's my trustworthy? Oopsie. Please. Maybe if I push the end a bit. Yes. Comb. What the fuck is this? Stupid ass fucking virus. There is no space. I mean, yeah, sure, this does fit, but I don't want to utilize this uncleaned shit. Oh, please. Okay. Looks it's going in. Great. So the other end will go into the bubble, I suppose. Which I think doesn't need the terminal block. Need to find the bubble. These are just five long bubbles. Isn't there like a 3 long bubble somewhere? No, of course not. Great. There is no waggle whatsoever. What a lovely experience. Need to go up for one. Fuck. Whatever. Nothing. Fűrészportban van emberek tehetnek. So another wobble. Where do we put him? Here. So we would take this lead and put the other thing, which is this. Suppose I will also have to put some thing on this. Looks disgusting, to be honest. Let's say I think this will do. Good. Doesn't. Well, then we are going to have it fit into the mold. Okay. Crimp. Oh. Alright. So this goes into here. It's not too convenient or like convincing. Yeah. Is it connecting? Yeah, I think so. Okay. And then we put the normally open here so that we do not zap ourselves in the process. Normally open is the right one. Because NC is not what we want. At least not right now. Come on. Fuck. I'm going to spin this in. Spinjitsu. Okay. Good. Yeah. Good. Should have put this in before that. Or this does not work. Is this a fucking joke? Fuck this, man. Come on. Plug this out then. What? For the first time? This can go into this shit even further. Why the fuck am I not able to put it in? Need to. Now finally. Thank you very much. Alright. Securing this thing. Securing the other one as well. Great. And we are done. So if I would put this, plug this in, then nothing would happen. I'm thinking that I want to test it out, or do I want to test it out? Why not? So wires, alright, and the other ones are kind of secure, so those are not a problem. So yeah, this will do. So what I will now do is that I have done this. I'm not going to test it just yet. I'm just going to test that. I mean, I can test it without the power on. So if there is connection between the two things, basically I don't even need to plug this in. I need to only plug in the, and I can take off my scarf. What I only need to plug in is the MCU itself. Though I don't think, yeah, I have put the wires away. That's why it's good that this is a box, because I can put the wires and stuff in it. Also, the board is coming, so I will be able to hopefully soonish do the level sensor, which will be pretty fun, or maybe not. The multimeter. Put him to beep. Continuity mode. Need to launch the MATLAB application. Alright, beeps. Good. I will take myself into a smaller window. If I could click on this, and not this one, not this one. We'll wait till MATLAB opens and boots up. I was actually working on the planetary gearbox, and I was able to assemble this piece here, which is basically the carriage or carrier. This is the carrier, the green one, and you can see the planets there. Basically they rotate around in this ring here, like so. Only problem is these pins, you need to cut them to length, as well as like odd grooves to them, so that they basically can not fall down, meaning the planets. And yes, it would look something like this, and you would have the sun inside, which propels the whole carrier, and the carrier rotates around. It's kind of quite tough. I would probably need to wear this in. Need a good amount of grease to the teeth geometry itself, as well as like onto the, because they roll around the pins on Teflon tube sort of bushings, and that is a bit tight right now, but probably with time it will vary. So yeah. Okay. So yeah, made this little blood colors onto my finger, which is pretty nasty. So besides, let's continue. So we are here. We need to launch this application. I'm going to run, and then when we are not running because we are not in COM4, I mean, it is connected to the COM port 4, but I don't know why it is not technically. I hope it's just a bug, not... Yeah, it was just a bug. Alright. So, oh, actually, it was drawing the readings, but then it stopped for some reason, whatever. So here are the data. What we want is the data. I want to send him commands, which is done to this send and not map, but send and arm, acknowledged arm, which should be yes. And if I press the blue push button here, I don't know if it is visible onto yes. If I press the clicks the relay, you'll have to check with the multi, that this should not beep, but when I push the button, alright, let's go. Great. So we would have ignition. Good, very good. So that's a good sign. Okay, that is done. I will need to still add, so now it's going to be a bit more. I don't know why I wrote soldering to the head title, whatever. So what I will do now is that I will need to still write the code. So we're going to hop onto the PC, and then we are going to do this. Yeah. I will need to do a few more things. So this is done. That's good. I will disconnect the PC. I will still need him, so I will just hang it here because I will need to make the. I will tell you the commanding for the pub, though I am not sure what I should how I should do it. So first of all, I will just go and ask ChatGPT a few questions about the topic, because I don't exactly know how the procedure should be carried out. So I'm going to do that. So the theme of this week is that people do not want the truth. You must choose who you share your deepest thoughts with, because most people just will ignore you and ghost you afterwards. They will not give a fuck. Meaning that if you talk about your deepest thinkings like I do here, most people would just find that too heavy, they would bail out. So this is like a deep thing, deep talking, deep conversation, which you cannot do with most people, and you don't want to do it immediately when you know people. You want to maybe progressively overload it in a relationship, so that you basically start light and then you increase the deep depth and the level of thoughts that you share with people, because they will just not give a fuck. If and and also that there is the other end, that you can talk about things in general, that let's say this period of my life is hard and all that, and that there is like a contained version, which is, I mean, I can show my face here. Basically, that you can talk about it in two ways. First is that it is contained, then basically you say that it's hard, and yeah, it's hard, but this is like self-chosen, so to speak. It is involuntarily suffering, so to speak, but you don't really explain more because they don't give a fuck, and you don't want to like ruin your reputation in that sense that they will take that. It's just like over explaining. When they ask that how are you doing, you are not going to just tell, well, in fact, I feel pretty shit nowadays because I'm going through a hard season, but I chose this voluntarily, and I don't have friends because you need, wait a sec. To be exceptional, you are by definition the exception, and that means that you are so much different from everyone else. You wouldn't talk like this to them, because it signals just weakness and like insecurity, and that you need to explain yourself. But what you would do is that maybe you tell that, yeah, it's not being the you think that this in your head, and then you say, yeah, I'm fine. I mean, that's kind of like probably how most people do it. I would say, if they ask this, first of all, ask that, do you really mean it? Do you really want to know? And if they say no, then you just don't give a shit. If yes, then you say that, hey, it's been a tough season, but I'm doing better than I thought, or like expected it to be easier, but I'm doing still well, holding on. So yeah, don't burden others with your own internal bullshit, because they will just ignore you, bail out, and nobody will talk to you. And guess how I know? Yeah, you're right about it. So, besides, let's go back and do this. So, what do we want? We wanna ask a few questions here that basically, how the fuck are they going, or are we going to do this? So, if I have the pump map mapped out, I have the blower mapped out, and I have already mapped out the stepper, so that I know how much air it provides per given amount of step position, which, yeah, sure, it changes if you home, and then sometimes for some reason the homing just doesn't want to stop. It just slams into the end limit switch, and then it basically just doesn't stop. The stepper just keeps pushing it and is like, you know, um, how do you say this, stalled out. So yeah, we'll have to fix that. But now I want to go into the burner. I would say first like a run-up test and checking things, you know, how I can ignite it and that I can even not blow it up or whatever, that I can run it stably. And I want to do it manually for now. I will still command the data via the command window in like MATLAB, so that's like kind of like a half automation. But yeah, how would you do it? Because it's I think it is very easy to overcomplicate it for the first time, because I want just want to start it, but then I will also want to later, or maybe in the same but probably in a different test, I want to test the safe limits, so basically where it is still a stable flame, but at that given, like first of all I would need to test the atomization error, how it affects the flame and the spraying. Second, that what is the stable region for the flame that I wanted to talk about, is that where it is lean, where it is makes bridge, and when it is, you know, when it can run and when it quenches off and all that kind of stuff. Yeah, then later on I would also on the automation, but that's for not for now, in the earlier stages. Maybe when I have the burner mapped out, then I would be able to do like a state machine in MATLAB, Simulink or Simulink, and have like a run up, but that's for a later stage. What do I need to measure in each step? How would you stage this? Really hope that it was able to pick it up. Sometimes it doesn't. Sometimes I need to just repeat myself, thank God it was able. Max time watchdog. Yeah, I will need to see how much half. Yeah, need a watchdog. And how much time it takes till it homes out. I can do that. Make like a lookup table, and then we will know how much time it takes, so that we can basically home back from each position, so that we know that 9,000 it takes like 4 seconds or 10 seconds, at like I mean at 1,000 rate, then it probably takes like 4 to 5 seconds. I mean 1,000 per sec, so that's 9, I would say. Yeah, you have to debug this first. So, I mean, I can read it out loud.
Robust homing logic works even if the switch interrupt fails. Two independent stop conditions during homing. 1. Limit switch active, debounced. 2. Max step count, max time watchdog, hard stop. Debounce requires switch active continuously for e.g. 20 to 50 milliseconds before accepting. Back off plus reapproach, hit switch, back off 2 to 5 millimeters, approach slowly until switch. If you can, use a driver feature, stall guard current sense, or a second hard end stop. Hardware, add RC filter or shielded cable if the end stop is noisy. Verify pull up down. If you still want to test burner meanwhile, do it with a fixed mechanical air setting, no homing
Yeah, we need to fix this first.
dependency. 1. Burner development staged plan. Manual first, no overcomplication. Stage A, cold checkout, no fuel, no ignition. Goal, verify airflow paths, sensors, and that nothing can run away. Actions, run blower at several points. Confirm air direction and that chamber exhaust is clear. Verify atomization airline flow range, if separate. Check leaks, soap solution, especially near fuel air mixing zone. Measure log, ambient plus inlet air temperature. Blower command versus measured flow P, you already have maps.
Oh.
Chamber static pressure, if you have it. Thermocouple sanity, room temp reads room temp. Safety. Add a master kill that drops fuel power. Relay MOSFET gate disable. Independent of MATLAB.
Master key that drops your relay. Relay is basically a off by nature, so that's not a problem. The MOSFET gate is basically switchable by the PSU, that's like a buster switch.
Add a software watchdog. If no command refresh in X seconds, fuel off. Stage B, ignition test. Short pulses, lowest risk. Goal, prove you can ignite reliably and extinguish safely. Setup, start with high ventilation, low fuel, and enough atomization air to avoid pooling. Use an ignition source you trust. Spark torch with a consistent method. Procedure 1, purge air, e.g. 5 to 10s. 2, ignite source on. Fuel, short pulse, e.g. 0.2 to 1.s, then stop. 4, if it lights, hold at very low steady fuel briefly, then shut down. Measure log minimum, timestamps for purge start, ignition on, fuel on off, fuel PWM, fuel head H, fuel temperature.
So basically we want to measure the timestamps for purge, ignition on, fuel on off. Fuel PWM, that is logged. Fuel head H, I'm gonna write that. Fuel temp, it's harder because I don't have any measuring points. Optimization air command, estimated flow, main air command, estimated flow. basically I would need a lot of air and just very minimum amount of fuel. So I would say like a 10% fuel, 10% pump. Run, yeah.
Atomization air command's estimated flow. Main air command estimated flow. Thermocouple. Fast logging. Criteria to move on. You can ignite in a repeatable way. You can shut down and the flame goes out promptly. No wet fuel accumulation.
Okay.
Stage C. Manual stable run mapping. Hold points. Goal. Run stable for minutes. Characterize good region without chasing limits. Approach. Pick 3 to 5 operating points only. Don't grid scan yet. Low, mid, high fuel. For each, adjust main air to get stable flame and acceptable temperature. Keep atomization air fixed initially one known good setting. At each steady point, e.g. 30 to 60s hold, log fuel, PWM, head H, fuel temp. Compute gene fuel from your map, corrected by T if possible. Air. Stepper positionless blower setting. Estimate Kinsey air or V air. Equivalence ratio estimate, rough, using AFR stoic and your estimated air fuel. Exhaust indicators if available. O2CO, even slow sensors help. Temperatures, chamber, exhaust, wall, whatever you have. Any stability observations, noise, oscillation, visible pulsation. Outputs, a first safe operating envelope, fuel PWM versus air setting that is stable. Number 2, stage D, stability boundary tests, lean blowout, rich limit. Do this only after stage C is boring and repeatable. Lean blowout test, safer direction than rich. At fixed fuel, decrease fuel slowly at fixed air or increase air slowly at fixed fuel. Stop immediately at instability signs. Audible oscillation, rapid T drop, flame flicker. Log, last stable point, first unstable point, time to recover, if you bring it.
Lean blowout, rich limit. Want to approach from lean, not rich, because you have extra fuel that can burn and that's not fun if it pulls up or some shit. Decreases fuel slow net fixed air. Decrease fuel flow. Ignition quality. So basically, for now we will just want to fix the limit switch, and then we want to assemble the burner. Alright, so we will start with the limit switch fixing. I'll go and make myself a tea, because I suppose this is going to take some time, probably like an hour. Till we implement this. Well, maybe other features, but that's okay. Tea break. Give myself 10 minutes, and I will come back. Right, trash in, trash out. Maybe I'll make. No, I don't care. Not going to take coffee. So yeah. Richie, that's it. I will order some stuff. We'll need to order a proto. I buy like 2 of these. Okay. Fuck off. We have this Mia version bullshit here. We have this Mia version. We need the female version. 1x4. And 40 pin, 20 pin, 60. The problem is that I can't. Though this is a better solution, cause yeah. Bruh. This is 40 long, the other one is 4 long. And this costs, this is a joke, isn't it? I will buy 2. I will cut them down in between then. Or I might, can you? You can't really cut them, can you? Yeah, that's the problem. You have to sacrifice one pin. You have to sacrifice one pin. Well, I guess still better than buying these. 4. 6, 8, 3. I suppose you want to buy like, isn't there 5? What? 2, 8. I suppose I will buy the fucking 80 long then, or 40 long. 2. Fuck the whole thing. Max 3 amps. That's a lot. Yes. Buy this. Need screw terminals. Yes. I need 2. So these for power in and for power out. I need 2, so I think these are the yeah, these are the 4, I would say, but which one is which? I think this is just that. This is half to 2.5, the black. Half to 2.5, half to 2.5. Let's go with the black. Buy like 5. It's not that expensive. 6. Like buying 10 is cheaper than buying 5. Or what? 6 is 600. Fine. And we can buy 10. Huh? What? The fuck? Hello? What? Buy 10. Not the black one, the green one, for fuck's sake. Okay. Also have this. We'll need the these are mini fit. Fuck this. Oh, come on. Yeah. Should have bought these. 2 to 2.5. I think I have bought these. Yes. Oh, 2 to 2.5. This is what I bought. Oh my god, this is so tiny. I will need to buy bigger ones for fuck's sake. Cluster. How big fucking cables can you fit in this shit? Not too big either. Oh fuck. I have these. Oh, maybe it's not even. Wait a minute. I might be able to see. Yes. Where the fuck are you? Oh, yes. Yes, this is why it is so. Oh, you can. Oh, here. Here you can connect them. Yeah. So we need these. Yes, this is bigger. I need like 5 of these. I'm gonna buy like 2 of the other ones. Yes, this is thick. This is the shit. Where is the other one? This was it. Yes. Let's buy like 5 of these as well. Alright. Huh? Whatever. What does this do? Nothing, it's just black. Okay. If we have these, let's say I would want to add 100 NF 7XR. How big is this? 1206. I think this is the small. I think the 1208 is no, 0805. That's the. Yeah, I think this is really small. What did I buy last time? A bunch of caps. A bunch of fucking caps. As well as caps. So yeah. Could buy this too. Could buy this shitty. F. This doesn't. Yes. Would want to buy the. Not this one. Yes. I will need to buy these things when my shit comes or arrives, so that I will be able to make the level sensors soldering. I will need to buy a proto board. We'll have this as well. We'll have the pinouts. Alright, I'm happy with this. Okay, we have bought 2 of this. Going to go and yes, proto board and nothing more. Okay, so we'll buy this. Don't care about this. Okay. Maybe I could have bought something else. Yeah, the wires. Yeah, the jumper wires. The jumper wires. I will need to buy jumper wires, which are quite expensive, to be honest. Yeah, I did this again. Where are we? Okay, turn this off. Will I do electronic work? No, I don't think so. Let me take this off. So yeah, 35. Almost on time, almost. So yeah. All right. All right. So the stepper homing is not the best. It's sometimes just, I don't know, for some reason doesn't want to do its job and it just doesn't stop. It basically is just wanting to move forward even though it hit the limit switch. So yeah, then we have to fix that first. Then I want to go on to the manual testing. First I will just want to manually check the blower and the atomization. then after when it is done with the homing as well, in like in situ, then I will test it with a very lean mixture. So basically I would note the um, delta H, so basically the head of the pump, and then I would command some fuel. I would first light the propane burner, and then start pumping the fuel, and then when the fuel is starting to light, then I would just add more burner or like blower air. What the interesting thing is that or like I don't know if we would need to for the first run to calculate out the atomization air and the blower air and all that kind of stuff. I think we won't, but tell me if I'm incorrect or not. And then after that we can later test the how the atomization air changes everything and how the other things are impacting the flame quality, and whether we can like test some things later on. But for now I want to just first check if everything is okay and working, and then want like a very brief pulse test. So I want to just pulse the fuel, and then I want to make like when it is like working with pulsing, then I would just run a continuous, I don't know, half a minute tests or something like that. So basically, what I have learned recently is that you can take your emotions and it's kind of like an interesting practice, but basically when you are feeling something intensive, this is called regulation, by the way. So when you feel something intensive and the emotions just you are just tired, or you are just feeling that hopeless, maybe like right now I am a bit I'm a bit frustrated, bit hopeless, or like anxious about this, that I'm not doing what I know like I do, because coding is like the black box for me. I don't know what I'm doing actually, and just welding and taping together the fucking pieces and helpers. So the main thing is that you feel these feelings and you just take a minute, you stop, you name it, you basically say that I don't know, I am anxious, that I don't know what I'm doing, and I am a bit hopeless. And then you just sit and feel the feeling. You don't do anything, you just focus on the feeling and bring the focus back to the feeling. It's kind of like meditation, but it's feeling the feeling and let it like settle and let it pass. Feelings are kind of like waves. When you are doing your thing and the feeling comes up, it's kind of weak, but when you focus on it, it gets stronger, the wave goes up, and when you wait, it dips down and it passes by. You want to train this basically this way. You just tell your like nervous system that you are stronger than the emotion, that you are stronger than the feeling itself, and it passes by, and then it doesn't have control over you. It's just a feeling, it's not a command. You basically want to tell that to yourself actually, that this is just a feeling, this is not a command, and I'm stronger than the emotion, I'm stronger than the feeling. And basically as you focus onto it, it just passes by, and this basically enables you so that you are less impulsive and less like you do less bad behavior. Basically you overeat less, you don't eat, like you basically do not require to listen to your emotions and how you feel. If you feel like jacking off, you are just going to sit there and say that yeah, I'm horny and I want to jack off, and basically I'm just really horny right now, and then you feel the sensation, and then you just sit there and focus on the emotion and wait till it passes by. It usually takes like 1 to 2 minutes, and then it just goes away. It's kind of wishy-washy, but it works, and this is required necessary for you to be basically doing things and to have like a still mind that you are regulating, because most people do not regulate, or because they actually they basically don't feel any like emotions that much. They numb, like when they are happy, no, I wouldn't say so, but in general, when they are sad, when they are angry, all that kind of stuff. And I speak from experience. When I was sad because I lost a lot of games in League, I was just hopping onto Pornhub and just jacking off immediately in like a minute. And you just numb, and basically you are not feeling the full sensation, the full emotion, which is a lot stronger than what you actually think it is. And basically this accumulates in you, and it resurfaces over and over again. And this is why basically this will limit you, because it comes back as like a compulsion over and over again, rather than you just having to sit down and just let the emotion pass, which is like a 2-minute thing, or maybe 5 minutes, and then you can continue your shit, rather than just watching a movie which is 2 hours, or like jacking off and taking the rest of the day off, or some bullshit like that. So yeah. So let's do this, shall we? Yeah. So let's go here. We have the burner. What is this? We have to add this watchdog. Check the pin. XT failed. Add the homing timeout. Specific code changes, high value. XT is enabled for the correct pin. Hall GPIO, I will need to, oh, I think it is open actually, yes, let's go. So what's this? What the name is? GPIO XT callback. Actually here it is. So PB GPIO pin, limit switch pin. If stepper stop. Yes, this is the problem. Because this goes to this. This doesn't have. This has this. This has this. Alright. Let's make it to 9,000. Let's go with 8. Home start MS. Where the fuck are we? STP homing van ha stepper home start MS hallgették. Main loop. Then in the main loop, if HTTP homing, step back top. Stopping team. Halt team disable. Step, GPIO port, step in. Build, let's see if there is any errors. Dun, 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 dun. Hopefully it works. Dun, 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 dun. Works. Alright. Save it into prototype 55. What is this? Yes, it's in burner and I think it's in the blower or what the fuck do I want? Yes, and I think here it's supposed to be. Maybe not. No. Compressor, yeah, here it is. Great. Dun, 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 dun. Hooray. Alright, fine. Alright. Fine. When I will fix this, then I will be able to then go to the next thing, which will be on this, doing the stepper now. If that's okay, then we can, I don't know if we have to implement any new things. I suppose we don't. Technically we could assemble the thing. Don't know, for some reason I'm really fucking tired, like I just beat to death or some shit. Move STP homing fallback. Okay. Not a problem. So then it is not that bad. I don't care about this. So it's technically good. Alright. I mean, what would we need to go to do? I mean, assemble everything. I don't know, for some reason I'm just fucking tired as shit. God damn it. I think I'm going to call it the day. Drop off for now. So yeah, thanks for watching. Tomorrow I'm going to assemble the whole thing and then going to assemble it and then set it up for test. Probably do some MATLAB thing as well. So